Assalamu alaikum, everyone. Let me share my screen with you. It is my honor and pleasure to be invited to speak at the Pakistan Society for Hepatology's annual conference once again, and to be asked to conduct a clinical research workshop. This year, we have divided the research workshop into two components. The first component will cover planning a research project. We will talk about what are the things you need to do before you start a project, what are the components of a good research project and the details, what are the common types of clinical studies that you can undertake, and how to execute a study. In the second part, we will talk about writing a good scientific paper. And we'll start off with the attributes of a good paper. We will talk about the key components of a paper, some general and specific guidelines, anticipating critique from the reviewers, and what to expect and what to do after you have submitted a research paper. So let's start off with part one, which is how to plan a research project. And I should mention that we focus on clinical research for the purpose of this workshop. So even before you start, it is important that you know your field very well. This can be achieved by doing a thorough literature search and by reading a lot about the topic. I also urge you to talk to your colleagues, your mentors, your potential collaborators, which will be critical in the success of your project. Think about your patients when you are designing a project, and think about the kind of questions that your patients ask you and the kind of questions that you have in your mind when you're seeing your patients, the answers of which you may not have and you would like to gather. You should you can look up current and recent work from many publicly available websites, including PubMed. There is an NIH website called Reporter, and this has a list of every funded NIH project, and you can search them by using keywords and mesh terms. You can also look at registries which have a list of clinical trials which are ongoing, which will help you understand where the field is headed. And you should always also look at society meeting and abstract books where preliminary findings of research are often presented. So before you start on a project, think of the relevance of the project to your clinical practice. Think of the availability of resources that would be required to conduct that, the time that would be needed, the logistics, and the people that you need to help you achieve the success in your project. Try to get the copies of previous projects or templates, which will help guide you through the process. And think as a critical reviewer at each step that you're designing or devising your project, so that you can anticipate some of the critique and some of the drawbacks, and you can address them right up front. I've tried to list some key steps in designing or developing a research project on this slide. I always urge people to start with a clinically relevant question. And it is important that the question is clinically relevant when you do clinical research, because you want your answers to inform other people to improve their practice or change their practice. Do a thorough literature search to see if others have already answered that question or not. If there are 100 papers or more which have adequately answered the question that you're trying to answer, then there's probably no need to do another study and waste your resources. Maybe you should think of a different project or a different question. On the other hand, if there is controversy on the topic, or the question is not been adequately answered or not answered at all, this would be a good project for you to do. Once you've done that background check, that you develop a specific aims and hypotheses, and we will talk about those in the next few slides. After that, you develop the specific study design and the tools and things you will need to conduct the research project. This should also include a statistical analysis plan and calculation of sample size and power. Also, do not forget the regulatory and reporting requirements for studies, which are a critical piece of designing a research project. So when you're designing or developing research projects, what are the kind of clinically relevant questions that you can ask and answer? You can ask about the presence or absence of a certain disease or diagnosis, the accuracy of that diagnosis, the incidence and prevalence of the disease or a condition in specific populations or subpopulations. You can look at the factors associated with the disease, the natural history of whichever condition you are studying and the outcomes of that condition, the efficacy and effectiveness of treatment and its impact on outcomes. In certain types of studies, you can also try to study the cause of the disease, or at least the associations that increase or decrease the risk of disease. You can try to determine the efficacy of screening strategies for diseases and clinical conditions. And you can also look at cost benefit and cost effectiveness of interventions. And equally importantly, what will be the cost to the society and cost to the patient if you do not do the proper intervention in time. Outcomes are obviously one of the most important things you need to define when you are developing a research project. And here I've listed some of the common outcomes, and I list them, I call them the 6 Ds. These include death, presence or absence of disease, discomfort, disability, dissatisfaction, or disparities. Obviously, there are more outcomes that you can think of, which will be applicable to the specific type of question that you're trying to answer. On this slide, I list components of a research project application. And the reason I list that is because there's a fair amount of overlap out here. A research plan, which is developing a study project, is a part of this. Some of the other components will be very helpful to you in terms of overall conduct of your research project. But because of time and because of the focus of this today's research workshop, we'll concentrate on the research plan part. There are 5 main components of a research plan. Each component may have subcomponents where you provide more details about that specific component. The templates and order of these may vary from one project to another, but these are the basic broad outlines. You may want to start with the background and significance, list specific aims and hypotheses, present your preliminary data, share your research strategy, and then address all the regulatory and monitoring concerns that are vitally important. So let's start with the background and significance. Background is what clarifies what is known and what others have done so far. The reason you do that is it helps you find gaps in the current knowledge and how to plug those gaps. It also helps you identify limitations of the existing studies. Significance, on the other hand, helps you crystallize what is novel and innovative about your study, how your project will increase knowledge in the field, and how is it different from what others have done before, and how will it transform care of your patients or patients in general in the short and long term. And also try to relate it to the bigger picture of betterment of individuals, of improved public health, or impact on populations as a whole. The next part of that is the preliminary data. And how does that help you? Well, when doing a research project, preliminary data is not critical, but when you're writing a grant application, this can be an absolutely critical part of your application and would determine your success. But in terms of how it can help you, it helps you generate and refine your question or questions, which will support the hypotheses that you postulate. It helps you provide the background and context of what you're trying to do. It helps you determine the sample size and power, and helps identify potential pitfalls that you may encounter. So this is a kind of a series of steps that that I generally recommend in developing hypothesis and specific aims. Start with the general idea, develop that into a focused hypothesis, and we will discuss what a focused hypothesis is. Recheck current literature after you have done, after you've developed focused hypothesis to see if something has changed in the meanwhile. And then you plan your outline of the study and how will you test your hypothesis. What is the difference between a hypothesis and a specific aim? A specific aim is what you want to achieve through this proposal, and it is stated in slightly more general terms. For example, a specific aim could be, our specific aim is to determine the efficacy of agent X for condition Y and its impact on outcomes. Hypothesis, on the other hand, translates that into a statement or a question which you can test for statistical or mathematical truth. For example, the same specific aim can be written as a hypothesis as follows. treatment A will achieve a higher rate of cure than treatment B for condition X or condition Y. And you can also specify the exact amount of difference that you're expecting or trying to test. In other words, you can say that treatment A will achieve 10% better cure rate than treatment B for condition X, or whatever number you may want to put in. What are the characteristics of a successful hypothesis? A successful hypothesis is novel, meaning it generates novel or new data or new information. It is significant for your patients, for your population, maybe for population at a large level. It is relevant to the context that you're practicing medicine. It is focused, meaning it addresses something very specific, so that it's not all over the place. It is plausible. In other words, there is some amount of common sense that dictates that this is something that makes sense based on your individual experience or based on previously published literature. And importantly, it is achievable. So there's no point to propose a hypothesis which you know you will never be able to achieve. Now, moving on to the research design and methods. So this is the true science part of your project. This section will vary greatly with the type of studies that you propose. But regardless of how you put it, how you write it, there should be sufficient amount of detail of what you're proposing and how you will do it. And generally try to organize along your hypotheses, and always try to identify and lay down alternate approaches. It is very common not to achieve the results that you expected, and you should have alternate approaches to mitigate that risk if that happens. In terms of research design and methods, there are several subsections to this part, and generally these are the ones that I list out there. But again, depending on the question that you are trying to answer, there may be a few more subheadings or sections, or there may be a few less. But you always have to define the study population and where you're going to recruit the population from. What will be the exclusion and inclusion criteria for the subjects for your study? How will you collect data? What are the tools? What are the methods you will use? How do you define all variables that are going to go into your study? You have to understand and define the logistics in terms of how you will do what you propose that you will do. You should have an excellent team of people which should have enough expertise and, equally importantly, enough time to carry out what you're proposing to do. You should have a good statistical analysis plan in terms of how you will test the hypothesis that you propose, the summary statistics, if you need to do any advanced modeling to determine risk factors and so forth. You also need to calculate your sample size and power depending on which type of study you're doing, and always anticipate the limitations and risks and try to propose mitigation approaches to address those right up front. Here I list some of the types of clinical studies that are commonly done. And it is important to understand this because it will help you tailor your study to the question that you're trying to answer. You start with the question that, are you assigning an intervention or an exposure yourself, or is it already present in the population that you study? If you are assigning the exposure or intervention, then this is an experimental study. And if you are allocating or assigning this exposure or intervention randomly to two groups of people, with both groups having an equal chance to be in either group, then this is a randomized clinical trial. If you're not assigning that at random, then this is a non-randomized clinical trial. If you are not assigning an intervention, then this is an observational study. The next question you have to ask is there a comparison or a control group for this observation study? If there is no comparison group, then this is a descriptive study, and these include case reports and case series. If there is a comparison or a control group, then this becomes an analytical study. And there are three main types of analytical studies: cohort studies, case control studies, and cross-sectional studies. And we will define them a little more in the next few slides. As you move along from the right of your slide to the left of your slide, from case report to case series, all the way to randomized controlled trials, the strength of evidence that these generate increases. In other words, there's the hierarchy in study design with case reports and case series at the bottom, and randomized clinical trials right at the top in terms of their ability to provide strong evidence to support your hypothesis that you tested. So let's talk quickly and briefly about types of clinical studies, case control and cohort studies and RCTs. In case control studies, one group of subjects already has the outcome event at the time when information is being gathered about the risk factors. The control group does not have to have the outcome. The two groups are compared, the case group where you have the outcomes and the control group where you don't have the outcomes. You compare the groups to see what were the exposures or risk factors that were associated with this outcome. For example, you could study acute myocardial infarction in persons with hepatitis C virus infection. If you design a case control study, all persons will have hep C. Some will have acute myocardial infarction and some will not have acute myocardial infarction. You determine what factors were associated with acute myocardial infarction. So this becomes a case control study in which the cases were those with acute MI and controls were those who did not have MI. The advantages of a case control study is that this is good for uncommon or rare diseases because you've already identified all persons with the outcome and all persons which are appropriate controls without the outcome. Therefore, there is no need to wait for a long period of time for the outcome or disease to develop. It can help in determining causality in such cases in less time and with less expense. The disadvantages are related to the control group mostly because you as an investigator create a comparison or a control group, and therefore some selection bias or a confounding bias can creep in. To avoid that, you should select cases and controls from the same base population, and the two groups should be otherwise similar in characteristics in every way that you can possibly do. In other words, you match the cases with controls as best as you can. Cohort study, on the other hand, includes other type of studies where all subjects are free of the outcome event at the time of first measurement. And subjects with a defined risk factor within those groups are compared with those without the risk factor to determine who develops the disease or outcome event. Taking the same example of HCV and acute MI, a cohort study design would be a base population in which some people have hep C and some do not have hep C, but everyone is free of acute MI at baseline. And then you follow them up and determine the role of hep C and other factors in development of acute myocardial infarction. The advantages of this type of study are that it can establish true risk over time. And the logic is the same as the clinical question. If you're exposed to a certain thing, does that person get the disease? You can assess the relationship between exposure and many diseases at the same time. The disadvantages are that it is inefficient particularly for uncommon diseases, and becomes very expensive when the outcome events are rare. And if the outcome events are rare, then you need a long duration for the results to be available. Clinical trials are at the top of the evidence chain in clinical studies. The advantages are that these are the gold standard for determining effect of interventions. They minimize the bias because you balance the two groups right up front, and they can determine causality. The disadvantages are that they're very, very costly to run, and you may require large numbers and long durations depending on what outcome you're looking at and the frequency of the outcomes. And you may encounter difficulty in enrollment, but the cost and time involved is the most important limitation of this type of studies. Other considerations in research design methods are there's always an issue of missing data, and there are strategies that you can deploy to address that. You can do imputations of various sorts, or you can do analysis with or without missing data. So there are robust statistical techniques that you can use to address that. There is always a risk of attrition of study subjects who are lost to follow-up. You may experience unexpected outcomes and limitations of your approach may limit the validity or the conduct of the study. And you have to think of these things up front and propose some alternate approaches even before you start your studies. Other non-science related things, but equally important things include personnel and budget. You have to identify your co-investigators and collaborators and consultants and support staff. The key thing here is that each person should add value and critical expertise to your study. You need to have diverse expertise in all areas of the project. You need to have subject matter expertise, design expertise. You need coordinators, statisticians, regulatory experts, and others depending on the type of study. Budget requirements may vary, but they often come with a cost, whether it's a cost in actual hard money or time or effort. But regardless of the requirements, regardless of what the cost would be, you have to have a justification for each item that that you're going to ask for money or going to employ. Include direct and indirect costs, and make sure that you ask for enough to carry out the project. Think about the travel costs, think about publication costs, presentation costs, and so forth. So all those costs need to be in your mind when devising or developing a research project. I cannot emphasize enough the importance of human subject protection in clinical studies. When you are doing an intervention study or where you're recruiting subjects, an informed consent is an absolute must. For all clinical trials, you need to have stopping rules or futility rules, and you also need to have a data safety monitoring board, which is independent of the study team. Always think about including special groups and underrepresented groups like women, children, and minorities. So unless there is a specific contraindication or a specific reason not to include them, you should make an effort to include as many subjects from these diverse groups as possible. And make sure that there are adequate measures in place for maintaining confidentiality and data security of all occupations and subjects. In large academic centers, there are several levels of approvals which are required before you start a project. Your division chief, your department chair, the dean's office, the office of research of the university or medical school or hospital. All of them may need to approve your study before it moves on to the IRB. And IRB or ethics board is an absolute must before you do any research related activity. So in this slide, in this final slide, I summarize the steps in developing a research project. Start with a clearly defined question, know your field very well in depth, determine the resources and the logistics you will need to carry out the project successfully, lay out a well-designed, well-thought-out strategy, obtain all approvals, and then you can start your project. We will stop here and we will open the forum for discussion and case studies if you have some questions that you brought with you regarding your studies or studies or research methodology in general. I will be happy to answer those.